What you are hearing is the sound of this picture being beamed down by a satellite orbiting 800 kilometers above the surface of the Earth. By the time you are seeing this, the satellite that I took this picture from will have been decommissioned, powered down and put into a safe electrical state. It will drift above the Earth for another 100 or so odd years before it will someday fall out of orbit and burn up in the atmosphere, but it will spend those years silently. This satellite was the last of its kind, the very last satellite left, chirping this lonely song. And on August 19th, 2025, it stopped too. And after it, nothing, nowhere, will make this sort of sound ever again. Automatic picture transmission. That's the name of the sound you just heard. Developed in the 1960s, APT is an analog format and has been mostly superseded by more modern digital protocols. But being older, it is notable as one of a few weather satellite protocols still broadcasted on the relatively low frequency VHF band, which is so accessible you could pick it up with, essentially, a bent piece of copper wire. I know because that's precisely what I used to take the picture I showed you at the start. Here's an example of a raw decoded APT image. There are two black and white channels, video A and video B, on the left and right respectively. Video B is usually taken at long-wave infrared, around 10.8 micrometers, and video A switches between the near-visible 0.86 micrometer wavelength during the day, or the mid-wave infrared at 3.75 micrometers during the night, when the sunlight doesn't illuminate the ground, and infrared is more useful. You can see the switch occur in this other image I took during sunset. The area on top is near visible, and then the brighter patch below is when it switched to infrared. It was remarkable to witness, as you could literally hear the sudden change in the signal. Here, listen. It's something very powerful about these analog image transmission formats is that you can hear the picture. The sound directly correlates with the brightness at each point. If you are familiar with SSTV, it's very similar to that. Satellites send a line via APT every half second, and that line is a horizontal scan of whatever is directly below, so you can figure out where each line is on the Earth if you know where the satellite was when it sent the line. This is how, for example, I can overlay a map onto this image. An artifact of this line-by-line transmission is the fact that for this image, you'll notice it's oriented with south at the top. That's because the satellite was traveling from south to north when I received the APT signal. Most images online will have such pictures rotated so that north is on the top, to match the most common projections of the Earth in maps. Like this one from Wikipedia. You can tell it's rotated because of the position of the minute markers on the sides. The minute markers mark a differently colored line each 120 lines, or 60 seconds, and is sent on the left side of each channel, so for rotated images, they'll end up on the right instead. On the other side is the telemetry section, which consists of 16 blocks of solid color. The first 9 blocks are for level calibration, ramping up in brightness, whereas blocks 10 to 15 transmit temperature data, and the last block identifies the channel. Half brightness for video B, and a quarter or 3/8 brightness for video A, depending on which mode it's on. Finally, the vertical lines before each channel synchronize the beginning of each horizontal line transmitted. Without this, the raw image can look like this, if the transmitter timing isn't perfect, which for old satellites is rather common. As a side note, you may have noticed that these images are in black and white, whereas the image I showed you at the start is in color. For APT, color is attained by mapping the two channels video A and B to visible colors, creating a false color image. Usually, you map the longer wavelength video B to yellow and the shorter wavelength video A to blue, before layering them together to get the false color image. For the past 4 years, only 3 satellites remain that use this analog image protocol. The NOAA 15, 18, and 19 satellites, so named after the American Weather Agency, NOAA, that manages them. By 2025, these satellites had far outlived their mission design life and were beginning to encounter failures from age and injury. This has prompted the NOAA to begin decommissioning them, suspending their transmissions and putting them in a passive state to reduce the risk that they might break down and create hazardous space junk. On June 6, 2025, NOAA 18 was the first of them to go silent. On June 16th, the NOAA stopped sending 15 and 19 data to meteorologists, although the satellites were left on for end-of-life testing. On August 9th, NOAA 19 experienced a battery failure and was preemptively shut down on the 13th, a week before the planned shutdown on the 18th. This left NOAA 15, planned to be shut down on the 12th, fill NOAA 19's place until the 19th of August, when it finally went quiet, too. And along with it, went APT broadcasts forever. I think I'm rather sentimental about old technology. There's something about things, once brilliant and new, heralds of a bright and beautiful future, becoming old and forgotten junk, that gets to me. In fact, it's not necessarily that APT was so accessible that gets me either. There are still a couple satellites, the Russian Meteor M2-3 and -4, that broadcast in LRPT, which can also be picked up by the same simple dipole antenna setup. LRPT is objectively better than APT2, at least technologically. It sends 3 channels, 6 lines a second, and 1 kilometer per pixel resolution. It's better and faster and more accurate than APT. But LRPT is digital, not analog, and directly modulated via phase shift keying into the VHF band at a frequency far, far beyond human hearing. Even if we could hear it, it would be a noisy mess of ones and zeros blazing along at no particular rhythm. I don't think I could get away with calling that a song, like I do the lonely chirping of APT. I think that's it, really. The loneliness. By the time I am writing this, days before its decommissioning, only the NOAA 15 remains powered and transmitting. It's the very last relic that speaks this obsolete language. I leave you with this picture I took from NOAA 15. It's the last one I ever received. I took it around sunset, and this is actually the same photo I showed earlier on, and as an example of the mode switching for video A. But here it is in false color. I'm particularly fond of the long shadows cast by the clouds in the upper atmosphere, dragging themselves across the surface of the Earth. These shadows must be dozens of kilometers long. When the satellite finally went over the horizon and its signal went out, I thought to myself silently about how I would never hear it ever again. I want to thank the people that created the resources I used to be able to receive from the NOAA satellites before they went quiet. I only learned about this whole affair August 7th, only a week before they were planned to be decommissioned, and it was these resources that made it possible for me to get everything together in time to listen to them. Links to the sources I used are below. Flowers of the World will return soon, I promise. I'm working hard on it, but I am now employed, so as a natural consequence, I don't have as much time for this. But yeah, I'm still working on it. Don't worry.